Welcome again to this month's episode of Ask the SOO. Hope you're enjoying what's left of your summer. This month we're going to talk a little bit about a phenomenon that usually occurs mostly in the summertime, and that's waterspouts. Let's start first with a climatology of waterspouts. Most often in southern South Carolina and the coastal Georgia areas, waterspouts are seen in the summertime, as can be shown in this histogram. Over 80% of the waterspouts in the last 10 years have occurred in the months of June, July, and August. However, they can occasionally occur at other times of year. There are two types of waterspouts. The most common is the non-supercell waterspout. That's usually what we see in the summertime when we're looking off the beach or maybe being out in a boat. Now, of course, we don't want to get too close to them, but in general, they're not too dangerous. However, the supercell waterspouts, which are fortunately less common, can be much more dangerous and at times even deadly. Non-supercell waterspouts form along lines of low-level convergence. That means that air is moving towards a common line from different directions. The most common location is along the land-sea breeze interface, although they can form along other boundaries which separate winds from different directions. Turning near the surface will develop along the convergence lines, then will be vertically extended into waterspouts. I'm going to show you a schematic animation of how this works. You can see the blue line representing the convergence with the arrows moving towards it in different directions. Then the circular rotations along the line underneath the clouds begin to get stretched as the clouds get taller. Eventually you get the formation of a complete waterspout vortex. Here are some facts about non-supercell waterspouts. They can form in families. In this image here taken off of Hilton Head a couple of summers ago, you can actually see 3 different waterspouts coming from the same cloud. They generally form in light winds, unlike their supercell counterparts, which form in high wind shear cases. Most waterspouts last less than 15 minutes. Only about a third of all waterspouts are actually accompanied by lightning. The full vortex of the waterspout is often not visible. You can see that here in example 2. Gale force winds are common within the vortex, which is why these are still dangerous to mariners. Normally they dissipate before they reach land, but not always. Occasionally you can see them come up on the beach. Non-supercell waterspouts are a challenge to forecasters because they are not easily seen on the radar. Here's a radar image as well as several pictures taken a couple of summers ago. You can see several waterspouts in the pictures, but there's nothing really strong on the radar. In fact, often it just looks like another shower on the radar. In addition, the vortexes of these non-supercell waterspouts are too small to be detected by the Doppler velocity in Doppler radar. Supercell waterspouts are an entirely different beast. They tend to form just like tornadoes do when you have high shear and strong fronts. They can move over water from land, or they can form over water. These type of waterspouts can cause devastation when moving on shore, just like a tornado. In this picture in the lower right, EF3 damage was caused by a waterspout that moved on shore. Fortunately, these types of waterspouts occur much less frequently. However, they can occur in the local area, and here is an example. On April 16th of 2011, a waterspout formed over Lake Moultrie came ashore and did EF1 damage in the town of St. Stephen. Let's take a look at the radar Doppler velocities for this event. In the upper left corner you can see where the reds and the greens are right next to each other. We have a mesocyclone. In this case it's a tightening mesocyclone right over the center of Lake Moultrie. As that mesocyclone moves towards the shoreline, we have the first visual report of a tornadic waterspout over the lake. About 4 minutes later, the waterspout moves onshore as a tornado. It starts approaching its peak EF1 intensity. There is extensive tree damage in the town of Russellville. Finally, the tornado reaches its high-end EF1 intensity. We have church and homes are damaged in St. Stephen. Fortunately, at this point, the mesocyclone starts to weaken, although a new mesocyclone does rapidly mature. So this is what some of the pictures look like. There's a picture of the waterspout as it was forming over Lake Moultrie. Here's a picture of some of the damage that occurred in the town of St. Stephen. Obviously, we had one building almost completely destroyed, some other buildings very badly damaged. That was not the whole story of April 16th, though. This area was actually at the southern end of a major tornado outbreak. This tornado outbreak wound up killing 24 people in the state of North Carolina and 2 more in the state of Virginia. Thanks again for joining us. We're going to go on a hiatus for the month of September so we can concentrate our efforts on a great series remembering Hurricane Hugo. We will be back in October to talk some about marine forecasting. Thanks again.